Chapter 10, Section 1 is the beginning of the geometry chapters, and this section covers the area of parallelograms and trapezoids. Start with the definition of base of a parallelogram. Base of a parallelogram is any chosen side of a parallelogram. Any chosen side of a parallelogram. Height of a parallelogram. The perpendicular, the upside down T means perpendicular. We've discussed that once already this year. The perpendicular distance between the base and its opposite side. Perpendicular distance between the base and its opposite side. Base of a trapezoid, the parallel sides of a trapezoid. Parallel sides of a trapezoid. Height of a trapezoid, the perpendicular distance between the bases. Perpendicular distance between the bases. Again, from the top. Base of a parallelogram, any chosen side of a parallelogram. Height of a parallelogram, the perpendicular distance between the base and its opposite side. Base of a trapezoid, the parallel sides of a trapezoid. Height of a trapezoid, the perpendicular distance between the bases. Now you can see in the next column there, I drew out these shapes and labeled the parts for you because mostly what you're going to be doing today is finding the area. Here's a parallelogram. There's two components you need to find the area of a parallelogram, the base and the height. Again, the base can be any side, but they happen to choose this bottom side. The height is whatever makes a right angle with that side. So as you can see, the height is this line up through the middle here. The height doesn't necessarily have to be, nor will it usually be, a side of the parallelogram. The height will be something else entirely on its own. Trapezoid down here at the bottom, trapezoid, slightly more complex formula, not that difficult, but just a little more complex than that. It's 1/2 times the sum of the bases times the height. A trapezoid has two bases, the parallel sides of the bases. So this is one of the bases, and this is the other base. Again, it's always the parallel sides. The height, just like in a parallelogram, has to make right angles with those. So the height will not generally, although it could be a little more frequently, not generally though, one of the sides that goes up with here. Okay, so let's go ahead and go into the examples here today. So you can see they're divided up. First three questions are parallelograms. Last three questions are trapezoids. These are not necessarily all the hardest problems. I will tell you the example 3 and 6 tend to be the hardest problems here for most people. In example 1, we're just supposed to find the area of the parallelogram. And you can see I'm abbreviating parallelogram quite a bit, as I am trapezoid, because I just don't want to keep writing it up. Find the area of the parallelogram. So again, area of a parallelogram is just base times the height. Base is any side. That's this. The height makes a right angle with it. That's this. So here you just got to do 12 times 9. 12 times 9 is 108, which is going to be the area. And remember, it's always units squared, so it's meters squared. 108 meters squared. Okay, example 2. A parallelogram has a base of length 10 inches and a height of length 8 inches. Find its area. Gentlemen, parallelogram has a base of length 10 inches and a height of length 8 inches. Find its area. Well, again, parallelogram area is just base times height. So you're just doing this problem. 10 times 8, no trick. 10 times 8 is, of course, 80. So it's 80 inches squared. All right, example 3 will be a challenge. Parallelogram has an area of 60 and perimeter of 120. If one set of sides is double the other, find the lengths of the sides. Parallelogram has an area of 60 and perimeter of 120. If one set of sides is double the other, find the lengths of the sides. Okay, so we're going to go through these problems in order because it will help us as we go right down the line with these numbers. Now, the first thing they tell us is that the area is 60. And we don't have any numbers to work with, so the first thing we're going to have to do is just list out all the multiples of 60, or all the factors of 60. So we can do 1 and 60 because 1 times 60 is 60. Could be 2 and 30. Could be 3 and 20. Could be 4 and 15. Could be 5 and 12. Could be 6 and 10. All of those multiplied together, respective list makes 60. All right, now remember what we talked about over here though with the parallelogram. With the base and the height, only one of those numbers is actually part of the parallelogram. This one here, the height, is not actually a side, and I want to know about both sides. So only one of these numbers here is actually part of the parallelogram. So we now know one side, but we're not exactly sure which one it is. All right, so we need to go to the next part. The perimeter now is 120. Okay? So if I add up the 4 sides, this, and this, have to make 120. Okay? I think we'd agree, assuming, let's just say we know this side here. All right? If we know this side has to be the same. That's what makes it a parallelogram. So it'd be in our best interest, since I actually know 2 sides, to go